All right, we are good. Okay. All right, so basically what we're going to do today is get a review of algebra. Hopefully this is a review. Okay. So we're going to review, so this is basically chapter P in the book. So if you go to the book, you'll have all these sections, P1, P2, this is chapter P. Okay. So instead of going through each section, because there's 9 sections in chapter P, which is basically your whole algebra course again, or integrated, whatever, we're just going to do the review, and then we'll hit some topics, okay? So basically, the topic for today is algebra review, all right? And as we go through, you'll see in the first couple, we're going to look at our sets and absolute value. Okay, so we'll get started with these two. All right, sets and absolute value. Okay, so just some basics. All right, and we'll list the first 4 that this clip will be on. Simplifying algebraic expressions, and we'll do exponents. All right, so this video that we're doing today will have these 4 topics on it on part 1. So we'll have probably a 2-part video for you and for the other ones to review. Okay, so let's get started. Now, obviously, I like to abbreviate. So if you don't understand my abbreviation has. So that's like, what's that's algebraic expressions. So if you don't understand okay. So sets. All right. What do we typically use for a set? How do we know something's in a set? Braces. We use braces. So we're going to say set A is a set of 1, 3, 5, 7. And we separate each part in there by a comma. What are each part? What's the term for that in a set? I'll give you a hint, it starts with E. I think one of Honda's cars, it has the name. Honda blank, starts with an E. Elements. Each piece in a set is called the elements. So if I said list the elements of the set A, you would say 1, 3, 5, 7. Okay. All right, and then 5, 6, 7, 8, 9, set B. And I'm just making something up, okay? We use capital letters. My review for you is to remember what the symbols mean for intersection and for union, to see if you remember. So if we said on this one, part A, find A intersect B. So that it's like an upside down U. This symbol here, this is read A intersect B. Okay, that's how it's read. Okay. And it has to be, it's looking for what elements are in A and also in B. Okay, they have to be in both sets. All right, so what element is contained in set A and is also contained in set B? And when you answer that question, you put a set. So you put the braces and you list them. Okay. So what? And of course, those elements are numbers. What numbers are in set A and also in set B? They have to be contained in each one to count. Okay. All right. Just take a second to answer it. All right. And what would you say? 5 and 7. That's the answer. Okay. 5 and 7. 5 and 7 are in A and also in set B. Okay? Have to be in both. All right, makes sense? All right, so that's intersect, and then what's the other one we said? What's the other term? A, U, it's an upside down, like, oh, it's actually like a U. So this is read A union B. And now it's the elements that are in set A or in set B, so it can be in either one. So the main word here is or. It's either in this one or this one. So what elements are in set A or set B? So basically, everything that's in set A and then everything that's in set B, just don't write the same number twice. So if the same number is contained in both, you don't write it twice. Okay. What do we have? Is 1 in A or B? Yes. Is 3 in A or B? Yes. What about 5? All right. Then instead of me putting 7, I'll skip over here and I'll put the 6. Then what about 7? Yes, then 8 and then 9. And that's how you do it. So it's the one that's in either, it can be in either or. Okay? Now just to look at the Venn diagram for each of these. What's a Venn diagram? What's your name again? Spencer, what's a Venn diagram, Spencer? Now what do you use? What geometrical figure? Circles. So the easiest way to show this with a Venn diagram that I like to see, if that's set A and that's set B, A intersect B would be this. It would be in the overlap. What has to be contained in both. And then A union B is this. Right? It's that one. It's everything in A or B. Okay? So if you shade it that way. So if I now put the numbers, right? So let's look at a Venn diagram for this. Here's set A, here's set B. So over here in what would be in this part of set A? This isn't in the homework, but I still want to touch on it. What would be over in this space? Not 5 and 7. Where do I got to put the 5 and 7? In this part, right? Because they're in, yeah, they're in both. And then what would be over here? There you go, 6, 8, 9. And now you can see, now you can get your answers, right? So A intersect B, that's that. A union B, it's all of them. There you go. Okay? So Venn diagrams help a lot. So later on, in maybe different topics, we'll come back to a Venn diagram. Okay, that's free right there. That wasn't in there. I just added that. Okay, any questions on sets? So those are the two main. They may ask you some vocabulary over those, and then also, what else was I going to say? They'll give you, it may not be numbers, maybe letters. A, B, C, D, E is in one set, D, E, E, F, G, whatever. You do the same stuff. Okay, easy peasy. You're supposed to say lemon squeezy. Never mind. I'm historically known for my jokes and stories. Have you heard about my notorious stories that I tell? No? That's the best part of this class. But you gotta be good, and I'll tell you like old stories from my past of crazy stuff that happened. Sets, we good? Bam, review of sets. Okay, what are the little things inside each set called? Elements. Now you also learned a new car. There used to be a Honda Element. I don't know if they still got it. It's like a little E. Yeah, you look like everybody's silent, like maybe that's like a nineties car and I forgot, I mean, it was before you were born. Huh? We're Googling it when we get done to see if there's still a Honda Element. Okay, absolute value. What does that ask for? I want to see what your answers are. What does that ask for? Distance from zero is exactly right. We just say, whatever's on the inside, make sure it comes out to be what? Positive, but the technical question is, what is the distance from zero? But if you're doing distance, then you know that this always has to be a positive answer. So yes, the answer is 5. So if you had a number line, right? There's 5. We want to know what's the distance. So that's why when you do -5, you do absolute value. Right? If you do absolute value -5, it should be the same distance, it's just to the left. So that distance is also 5. That's why we say absolute value of -5 is 5. Because its distance from 0 is 5. Those should not be difficult for you, but the ones I think might be difficult is something like this. How do I answer this? Oh, I put it, that's great. That's a made up math right there. What's the absolute value of 5 minus square root of 2? Oh, never mind. Square root of 2 minus 5. Let's do that. What's the absolute value of square root of 2 minus 5? So this is where you got to be careful. Just say, well, whatever's on the inside, make it positive. Be careful. So what you haven't done is you haven't gone to your calculator. Okay? But if you go to your calculator, it will help you. Type in square root of 2 minus 5 on your calculator and see what the answer is. See what you get. And then from there, we'll see what answer you want to give. So what do you get when you did square root of 2 minus 5? Give me the first letter of your name right here. Don't tell me your name. Give me the first letter. Zoe. That's easy. All right, Zoe. What do you get when you type that in? -3.5857. Now does it make the problem easier? If I said, what's the absolute value of -3.5857, what are you going to say? 3.5857. If you know that whatever's here, if it's negative, you just got to make it positive. But you're going to see that's not going to be the answer because the answer is going to leave it in exact form. Exact form means you cannot type in the square root on your calculator. You got to leave it as square root. So yes, the answer is 3.5857. That's the answer, but the problem is that's a decimal. We got to leave it exact. So this is like an approximation. We need to leave in exact form. So let me ask you this. Technically, what are you doing from here to here? What math are you doing to get this? How do you go from this number in here to this answer? Instead of taking the negative out, what's another way to get rid of the negative? She's right, the negative is disappearing, but what's another way to get rid of a negative in math rather than just remove it? Very good. You're multiplying by a negative. Right? Because -5, if it's negative, I multiply -5 times -1 and I get 5. You multiply by the negative. If you multiply this by -1, you get 3.5857, whatever. Okay? My point is, that's how you go from this to the answer, negate it. So what's the absolute value of square root of 2 minus 5? Well, I know it's negative, because I know square root of 2 is smaller than 5. So if I negate it, this becomes what? If I multiply the inside by a negative, what does square root of 2 become? Negative square root of 2. What does negative 5 become? No, it's already a negative. Positive. So if you multiply this, you should get negative square root of 2 plus 5, or 5 minus square root of 2. That's the answer. That is 3.5857. Everybody see how I got 5 minus square root of 2? What did I multiply square root of 2 minus 5 by? Look, here. So let's go back to it. Negative 5. We said what? Multiply by negative 1. What do you get? 5. Square root of 2 minus 5. Multiply by negative 1. Well, when you multiply by negative 1, you got to distribute the negative 1 to both. I get negative square root of 2 plus 5. That's what that, and then, so all I did was just switch the spot of these. What's that called in addition? If you say this and this are the same, when I change the place of them, what is that called? What property? Commutative property. 5 plus 3 is 3 plus 5. All right. Look at, this one is one that students, I notice, have trouble with. That the opposite of this, you just switch the order. So for instance, if I said the absolute value of 3 minus 5, well, we all know that that number is what? What's 3 minus 5? Negative 2. So the answer should be what? 2, which is 5 minus 3. If you switch the order, it negates. See, if you have a minus sign, if you switch the order, you get the opposite answer. Does everybody see that? 2 minus 7. If I had absolute value of that, what would the answer be? The answer is 5, but switch the order. What do you get? Switch the order. 2 minus 7. Switch the order. 7 minus 2. That's the opposite. That's what my point is. If you want to make the opposite and you have a subtraction in there, switch the order, which is 5. Now, you don't need to do it on something like this. If you had 9 minus 3, you don't switch the order. Why not? What's the answer? Who's saying it? Raise your hand. Who's talking? Because I can't. Yes? It's already positive. So what's the answer? 6. You don't need to make it opposite. Okay? So over here, that's why I messed up. What was wrong with this question? It's already positive, because square root of 2 is like 1.4. So 5 minus 1.4 is positive, so you would just leave it like that. Okay? All right. So you've got a little bit of you need to investigate whether that inside is negative. If you want to make it positive, switch the order around the minus sign. Got it? Okay. Well, here's the thing. If we've gone too fast or you need to see something again, guess what you get to do later? Press play. Because you're going to get the YouTube, you're going to get the video. How am I doing on time, boss? 8 minutes. 8 minutes. All right. We'll for sure get through the algebraic expression. I doubt we're going to get to exponents. Oops. All right. This one's easy. On simplifying, here we got, so we've touched on absolute value. Simplifying algebraic expression. Here's an example. If you simplify, what's another term for simplifying? What if I said simplify? What's another word for that? If I said simplify that expression. No, it's not solve that, so be careful. There's nothing to solve. That's why it's called an expression. So the terminology here is simplify the expression. The word solve should not be used. It's called an expression. Why is it called an expression and why do I not use the word solve? There's no equal sign, very good. Only in equations do you solve. There's no equal sign. It's just boom, simplify. What does simplify mean? What's a synonym?
Small.
What's that?
Smaller.
Smaller, reduce. I like to say reduce. So simplify means reduce, make it smaller. Okay? So typically, how are you going to start this problem? We need to make this expression smaller if we can. Where do you start? You start left to right, like you start at the 9? Where do you go first? That's the question. What do you think, Mac? What's that? It's okay. I mean, you're either going to be right, and if it's not right, we'll fix it, and we'll all learn from it. What do you think we should do first? That's exactly what you do. You always start inside. You work your way inside out. So go in here first and work this, and then therefore, that's more nested there. So always just work inside out when you have nesting. Okay? Because we want to get rid of the brackets so that we can CLT. Our goal is to CLT. What's CLT? Chicken, lettuce, and tomato sandwich, unfortunately, they don't serve them in the cafeteria. No, it stands for combine like terms. You cannot combine until you start getting rid of those brackets and parentheses. So we want a CLT, and we're going to do what Max said, work inside out. Go ahead. Get this as simple as possible. She gave you the first hint, work inside out. Then Ashton's going to give us the answer in a second. If we have an Ashton in here who wears a green shirt. This is a problem. I can't pause it because if I hit anything, it cuts the video. And I got to restart the video. So you just have to fast forward at these moments. All right. Ashton, did you get to an answer? You want to give us something?
No.
No, didn't get to anything. So what do you think is the first step?
The 2?
No.
No.
Work inside out. So you go in here, 6x minus 3, there's nothing I can do. Then the next thing, there's a negative in front. What do you think I should do with this negative? If you have a negative in front of parentheses, you distribute. This is what we mean by inside out. So the first step should have been to distribute this minus. Now you have negative 6x plus 3. Okay? Now what do you think you should do? The 4 and yeah, on the inside of the brackets, because I'm still working inside, I'll combine this 4 and 3, and I can make it 7 minus 6x like that. Now, are inside the bracket as simple as possible. But I can still go further, right? What's next? No. You distribute the negative 2. Leave the 9 alone. This is a 2 in front, you distribute. And I would just distribute the 2 and then negate it. Or you can distribute the negative 2 however you want. So if you think of the negative 2 being multiplied, if we just do it like that, like you said, that'd be minus 14 plus 12x. And now we're almost done. See, I distributed the negative 2, so the minus and the 2. And now I'm almost done. What's the final answer? What's that? 12x minus 5. You're exactly right. It's kind of taboo to start with a minus. So -5 plus 12x, you can also write it 12x minus 5. And when you change the order and it's still true, it's called what? What property is that? That's the commutative property. I'm just listing that because they may ask you a couple of properties. But yeah, either one of those is fine. Okay? They're both equivalent. So where did we work? Inside out. You'll get some practice with some of those. Okay? All right.
And 3 seconds.
Yeah. We're gonna stop right there. All right, this will be the end of part 1 of today's lesson.